Hello and a very good day I bid to all. Today we will present to you about the group 1 and group 2 elements in the periodic table. First of all, the group 1 element. The group 1 elements, also known as alkali metals, which are lithium, sodium, potassium, rubidium, cesium, and francium. And just like their names, all of these elements are metals and have soft and shiny appearances. Alkali metals have to store in oil and need to be handled with care, as they are very reactive metals. And just like the other metals, alkali metals also a good conductor of heat and electricity. Next, the physical properties of the group 1 element. The atomic size increases down the group. Second, the density of the group 1 element increases down the group. Next is the electropositivity and reactivity of the group 1 element increases down the group. Lastly, the melting and boiling point decreases when descending the group. The atomic size of elements in group 1 increases down the group. This is because the number of field of electron shells increases when descending the group. Thus, the distance between valence electron and the nucleus increases, which makes them have a bigger atomic size. For example, sodium will have a bigger atomic size compared to the lithium, as sodium have 3 shells filled with electron compared to the lithium who have 2 shells filled with electron. Next, density. The density increases gradually when down the group. This is because of the atomic mass increases when descending the group, which means that the francium will have highest density in the group 1 elements. Next, electropositivity and reactivity. As the atomic radius becomes larger down the group, the force of attraction between nucleus and valence electron becomes weaker. Hence, the atom will lose electron easily and increasing the electropositivity and reactivity of the elements in group 1. For example, potassium, who has bigger atomic radius, will release electron more easily compared to the sodium and lithium, which means that potassium will have higher electropositivity and reactivity compared to the lithium and sodium. Melting and boiling point. Opposite to the other properties, melting and boiling point will decreases when descending the group. This is because the metallic bond between atoms becomes weaker down the group as the atomic size increases. Thus, less energy needed to break down the bond, which makes them have lower melting and boiling point. Now we had learned about the physical properties of the group 1 element. We will proceed about the chemical properties of the element in the group 1. All of the elements in the group 1 have same chemical properties as all of them have one valence electron. The elements in the group 1 will react with oxygen to form metal oxide, and then will react with water to produce metal hydroxide and hydrogen gas, and also can react with halogens to form metal chloride.
Hi, my name is Chihin, and I'll be sharing about the reactions between the group 1 elements with oxygen gas. So based on the reactions below, we could be able to see that if alkali metals react with oxygen gas, and eventually it will form a metal oxide. So for an example, if lithium reacts with oxygen, hence we could get lithium oxide as our product. So moving on to the next slide. Okay, so this table shows the observations when alkali metals are burned in oxygen. So as we can see that alkali metals react differently while burning with different colors of flame. So if we take potassium as one of the example, we could notice that a white potassium peroxide, which is Na2O2, and a potassium superoxide, KO2, is formed when potassium burns very vigorously with lilac flame. Okay, so proceeding to the next slide. Next, we'll be playing a short video about the reaction between the water and the group 1 elements.
Another way of comparing reactivity is to place the metals in water. Lithium floats. It reacts immediately, fizzing and skating around on the water, which is evidence that a gas is being produced. By carefully putting a tiny amount into a boiling tube, the gas can be tested with a lit splint. A squeaky pop means it's hydrogen. Universal indicator shows that at the end of the reaction, the solution is alkaline. Lithium reacts with water to form lithium hydroxide and hydrogen. So how does sodium react? Again, it floats on the water and fizzes. The gas produced is hydrogen. And the solution is alkaline. When sodium reacts with water, sodium hydroxide and hydrogen are formed. Sodium is more reactive than lithium. It's below lithium in the periodic table. Potassium is below sodium. So how do you expect potassium to behave? Potassium is definitely more reactive than sodium and lithium. It reacts immediately, and the hydrogen produced ignites on its own. Universal indicator goes blue. Potassium reacts with water to form potassium hydroxide and hydrogen.
So after watching this video, we all know that if water reacts with alkaline metals, the product will be hydrogen gas and a metal hydroxide. So for example, if sodium reacts with water, hence we'll be able to get sodium hydroxide and a hydrogen gas as our product. So moving on to the next slide. Okay, so these were the observations of alkaline metals when cold water is added. So according to the table, we could observe that the buoyancy of the alkaline metals are decreasing as they go down the group. And apart from that, the reactions becomes faster and more vigorous while going down the group. And hence, eventually, they dissolve to give a colorless solution, which is extremely basic. Okay, so if we react halogens with alkaline metals, the product will definitely be a metal halide. So for example, if we react iodine and potassium, eventually a potassium iodide will be produced. Okay, so the table below shows the observations when alkaline metals burns in chlorine gas. Referring to the table, we could notice that the metals burns brightly while going down the group, following by different colors of flame. And lastly, a white solid will be obtained from the reactions above. So I think that's all for my part, and I'll pass the rest to Alif and Josh. Thank you.
Okay, so I'll talk about group 2 elements, which are the alkaline earth metals. Why is it called alkaline earth metals? It is because of the alkaline metals is because when they will form alkaline solution when they mix with water, and it's called earth metals is because the oxides do not dissolve in water and it is resistant to heat. And in group 2 elements, the alkaline earth metals consist of 6 elements, which are beryllium, magnesium, calcium, strontium, barium, and radium. And next, we'll move on to physical properties, which is the properties that can be determined without changing the elements in any form. And the physical properties in the group 2 elements are low density, low melting point and boiling point, except beryllium. They are also soft and strong in their metal states. They are ductile, which is the ability of a material to be drawn or plastically deformed without fracture, and malleable, which is the property of a metal's ability to be distorted below compression. The group 2 elements are also shiny and silvery as metals, and they have a dull appearance. And next, I'll move on to the chemical properties, which are they are relatively reactive, but less than high reactive alkali metals. And they also form halides when reacted with halogen. For example, calcium fluoride, CaF2, which is also used to make lenses to focus infrared lights. The group 2 elements also form oxides when reacting with air, leading to a dull appearance in pure form. They also form 2+ charge in cationic forms, and the group 2 elements also form ionic bonds with other negatively charged ionic forms of elements. For example, of common compounds are calcium carbonate used in chalk and strontium nitrate used in fireworks.
All right, let's look at the group 2 reaction. First of all, we will see when it reacts with hydrochloric acid, the observations that we can see is that it will produce bubbles of hydrogen gas and a colorless solution of the metal chloride. We can take here magnesium as an example. So when magnesium reacted with hydrochloric acid, then magnesium chloride will be produced and there will be also a hydrogen gas. And we also have to take note that along down the group, the reaction will become more vigorous. And also, next we will see that reactions with nitric acid. When group 2 reacts with nitric acid, the observations that we can see is that the reaction will produce hydrogen ions as well. But then when we dealing with the concentrated nitric acid, nitrogen dioxide will be formed directly, and we'll be talking more about that later. And we can see here, we'll take calcium as an example. When it reacts with nitric acid, calcium and next, there is calcium, strontium, and barium. So we can see here is that strontium and barium is actually essentially insoluble. So the similarity that both of these, what they have is that when they are exposed to the sulfate acid, a layer of insoluble sulfate is formed on each of these metals, which will slow down the reaction or will absolutely stop them. And for calcium, it is slightly soluble, and some hydrogen will be produced when reacted with sulfate acid, and we will also observe a white precipitate of calcium sulfate. For the other two groups, for the other metals in group 2, hydrogen gas will be produced from a very dilute nitric acid, but this gas will be contaminated with nitrogen oxides. It depends on the concentration of the nitric acid. And colorless solutions of the metal nitrates are also will be formed. So firstly, we can see that solution that is very dilute, the nitric acid that is dilute, hydrogen gas will be produced. However, when it's a moderate concentrations, and it will mostly also happens with a very dilute nitric acid sometimes. So we can see here that there is a nitrogen oxides will be produced when it form with the when magnesium is reacting with the nitric acid. And for lastly, when it's reacted with the concentrated acid, magnesium and nitric acid, it will produce a lot more nitrogen oxides. Yeah. When magnesium is reacting with the concentrated acid, um, hydrogen will also be produced. However, it will be more contaminated with the nitrogen oxide. And lastly, we will talk about the solubility. As it goes down the group, the solutions will be more alkaline. So as we can see here that MgOH2 is slightly more soluble in water. However, barium hydroxide is much more soluble more than magnesium oxide. This is because barium is more below than magnesium. So what we can take from here is that the metal ions get larger, so charge density decreases. It will also get a lower attraction between the hydroxide ions and larger ions, and the ions will split away from each other more easily. Therefore, there will be a greater concentration of hydroxide ions in water. And that's all from our group. Thank you very much.